Hello everyone. Uh, I would like to give everyone a warm welcome on the behalf of IEEE YMCA. So the speaker is with us. We'll wait for another 5 minutes.
Hello and welcome everyone. We are here today for a webinar covering robotics and STEM development being organized by IEEE YMCA student branch. I'm super excited to have you here. Excited about the conversation we will get to have today. We have Miss Danielle Boyer with us, an indigenous teen entrepreneur, educator, and author from Michigan, USA. She is the founder of STEAM Connection and focuses on increasing STEAM educational accessibility, diversity, and affordability. Some of you might be wondering what does STEAM stands for? Well, it means science, technology, education, arts, and maths. Now, without further ado, we will turn the time to Miss Danielle, our renowned speaker today.
Hello. Thank you so much for having me. If you don't mind, I'm going to share a presentation. I don't know if it'll let me as well. All right. Can you see my presentation? I just want to make sure. I've never used Google Meets before, so I just want to make sure it's all working. So thank you so much for having me. My name is Danielle Boyer, and I'm a teen in STEAM, which is science, technology, engineering, art, and math. So basically, I write books, invent robots, and teach others about STEAM. I'm from Michigan in the United States. I'm also indigenous. In the United States, there's different indigenous people groups. So basically people who lived in the US first before colonizers came. And so my people group is from the Michigan area originally, and so I'm Ojibwe. And I'm mixed, which is why I look like this. So what do I do? So as I said, I'm a teen entrepreneur, educator, author, and inventor. So I started the STEAM Connection, which is my nonprofit 501c3 organization, in January of 2019, but I've been doing work in entrepreneurship, especially with my dad, who's an entrepreneur, since I was around 10 years old. I started the STEAM Connection to be able to serve kids better, especially through education and engineering, and I knew a nonprofit was the best way to do that. Regarding education, I teach and bring my resources to tens of thousands of children. I actually mentor 35 FIRST and VEX robotics teams. So FIRST stands for Inspiration and Recognition of Science and Technology. And I work with over 900 kids one-on-one just through FIRST and VEX. And in my state in Michigan, we have different programs for kids grades K through 12. So, you know, the youngest schooling programs to the oldest. I work the most with the middle school students who are around like ages 11 to 12. Primarily those are the kids I work with, but there are more ages in middle school. I'm also an author. I have written 5 children's books and 1 STEAM activity book. And I'm working on more books with a publisher right now because currently I'm self-published, but I'm actually working on getting my stuff out there even more, which is really exciting. And they're all STEAM education focused because I really care about increasing diversity in STEAM specifically, because a lot of girls especially don't see themselves in different STEAM topics, and I want to change that. I'm also an inventor. So I invented a robot named Every Kid Gets a Robot that costs less than $20 and goes to kids for free. If my camera's on, if you can see, I have one of my circuits behind me that I designed. So I have been designing robots for a while now. I mentored my first robotics team when I was about 11 for my little sister. And then I was really inspired to bring accessible and affordable resources to kids. So I invented my own robotics kit. And I've also designed a robot for Dassault Systems, which is the parent company of SolidWorks. And as you can see in the pictures on my screen, I have worked quite a bit with them, and I'll talk more about that in a minute. So right now, regarding schooling, I'm studying both mechanical engineering and electrical engineering. I know there's a huge debate about which one's better, but I really couldn't choose. So I'm studying both right now, and I'm also a physics minor. I'm still in undergraduate school. I took a gap year, though, so I'm newer to my college studies than a lot of people my age are. but I really wanted a chance to start my nonprofit and to help as many people as possible and to travel as well. And thankfully, because of my corporate partnerships, I've been able to do that. So my goal ultimately is to pursue a career in bio robotics. So I would like to pursue a PhD in that. So there's two different types of bio robotics. I didn't know this was a career for the longest time, but there's two different types, and either you can mimic biological organisms mechanically or chemically. And I am very fascinated by the, mimicking biological organisms mechanically, and especially through using products like SolidWorks and even the electrical side of things. And so I would love to research that type of career, especially through the company called Boston Dynamics, who makes the robot that's quite famous called Spot. They've also made like the Sand Flea and many different robotics products, but I'm really inspired to hopefully work with them one day. And then I'm also interested in working in de-droning. So I know all the drone lovers are going to hate me, but I'm very interested in drone security and safety. So coming up with cost-effective solutions to increase safety for the general population. Drones have a lot of power, and I feel like we as engineers need to come up with better ways of ensuring that they're safe for the general population, and those safety products and those safety options shouldn't be crazy expensive and only available to football stadiums and sporting events and political events. So I would like to come up with options that would be available for everyone. So how did I get into STEAM? I have actually been doing this since I was 10 years old. I'm the one in the quite terrifying furry bucket hat right here. But I have been teaching since I was 10, and I was homeschooled for most of my life, which basically means my parents taught me, and I didn't go to a formal school for a very long time, it's mostly like religious related in our communities. It was not my thing at all. I really like school and I really like studying with other people, but I decided to use the opportunities that I had to teach kids, and somehow my community and parents let me teach when I was 10. I don't know why, but I pitched a curriculum and teaching model, and I was ultimately able to teach an animal science class when I was 10. And then I went on to teach a bunch of more classes. And since then I have taught, let me think about that. It adds a new one every day, especially with new virtual teaching models. I've taught, I believe, over 60 classes since I was 10, like just by myself. Through the STEAM Connection right now, I teach a lot of classes. In January of this year, I taught 20 because I took some more time off school, but I taught 20 classes for the community, and then I traveled for a month to be able to work with different companies and lecture and do school visits and that type of thing and talk about my experiences and interests in engineering. And that was a really cool experience. But I definitely nowadays, since I'm older, I encourage kids who are younger to get involved in STEAM education and in teaching their siblings and in their community. So if you guys have siblings who are younger, who are interested in this type of thing, it's definitely something to pursue, especially as virtual education is becoming a more and more prevalent thing, and we can teach people from anywhere. My recent teaching models have all been online. In fact, after I end this call, I have classes to teach. I'm talking about microbiology today, as well as inventions, but it is an amazing thing to be able to teach kids from anywhere in the world. So since then, since I was 10 years old, I've done a lot of really cool things through my different initiatives, through my projects, specifically to do with Every Kid Gets a Robot. And I have had some amazing opportunities to work with, for example, SolidWorks, parent company Dassault Systems. I've worked with different colleges. I've worked with the 3D printing nerd, different podcasts, things like that. It has been really, really amazing. I actually got discovered by SolidWorks. So I've been working in the STEAM education sector for a very long time, but I got discovered relatively recently when I was 17 years old at a FIRST robotics competition at the First Detroit World Championship, which is very near to where I live. And there's 2 world championships one in Houston in the United States, and then another one in Detroit in the United States. So I'm the closest to Detroit. It's actually in my state. So SolidWorks one day approached me, one of their representatives, and we were just talking about robots and stuff. And I handed them one of the books that I had designed for the team, because I was very much newer to the world of FIRST Robotics, in the sense of I was only on the team I was on for a year. I didn't have a ton of experience with that, but it was a great opportunity. I loved it. But anyways, I met SolidWorks and I showed them the work that I was doing, some of the CADs I had designed, some of my electrical work, and they were really fascinated by it. And their representative was like, I'm going to Japan for a month, email me after. And so I emailed them after, and they ended up writing a feature about me, which you can see in the bottom left corner here. And I was in their Women in Engineering series. And since then, my work has kind of taken off, which has been amazing. Most recently, I lectured at their 3D Experience World Conference. I was on the main stage. You can see it, the bottom right here. And I was able to talk about Every Kid Gets a Robot and using SolidWorks, the 3D Experience platform, like CATIA, as all amazing options for education. And I've been using the SolidWorks products myself for a very long time now. I think I've been using it since I was around 14 years old. I didn't have my own software for a very long time, but I ended up working with my different friends in the homeschool community and just used the software on their computers. And I was like, come on, please, can I use SolidWorks? I really, really want to use SolidWorks. And when I got to high school, I finally got my own software, and I was just designing up a storm. And thanks to SolidWorks, they've also given me like a 3D printer. They've given me different financial resources. And I also gave my first keynote through them as well. I gave my keynote at their 2018 User Advocacy Day, which was super fun. But yeah, since then, I also work with my students to do different things. Like, for example, right here, you can see my student I doing a SolidWorks Live. His name's Dakshish, and that was so much fun. We have been working together for a long time, and he's actually my resource manager through the STEAM Connection, and he's only 17 years old. He ended up nominating me for a Governor's Service Award, and I ended up winning, which is crazy. And we definitely work together to make awesome and cool things happen through STEAM. He's currently attending the University of Michigan for electrical engineering and business. So that's really cool. I love seeing my students go out and do amazing things. But yeah, I have done a lot of cool advertising campaigns, even for SolidWorks. I've been able to work with different interpreters through my projects. I have done, different speaking engagements. I've done different keynotes now, especially for the Indigenous community, so Native American, and that is really, really cool. Native Americans take up such a small percentage of the population in the United States, so it's really cool to have that community and to be able to work with a greater audience. But yeah, it has been really amazing, and only cooler things are happening. I just had a project come out from the American Society of Mechanical Engineers where they were talking about my work. And then I'm having some more stuff come out from engineering.com. So I'm excited about that. And it's definitely a full-time job doing things like press, especially while writing children's books, attending school with a double major, and distributing and inventing robots. But it is very much worth it. And I recommend to get involved in, one's community as much as one can. So the projects that I'm actually proudest of would have to be on the far right. We have that one of the advertising campaigns I did for SolidWorks of me looking really stupid with an astronaut. In the middle, that was me talking at 3D Experience World with their business strategy vice president, Suchit. And also on the left, the Governor's Service Award. That was really, really cool. I got to be up on a big stage. It was absolutely terrifying. I love things virtually now. I can give keynotes and not have to see anyone's face. So the STEAM Connection is a nonprofit organization that I founded in 2019 to bring technical learning to underserved populations. So underserved populations for my communities primarily mean Black students and Indigenous students. These students are very much underrepresented in STEM careers. And so I work to bridge that gap and to provide digital and technical learning in an affordable way so that everyone can access it. In my community, personally, my community is like 80% Asian. So most of the students I work with one-on-one, like in my city, are almost all Indian and Pakistani. So I definitely work to make STEAM accessible, affordable, diverse. Diversity is also very important to me, and representation, of course. So I bring in a lot of volunteers, speakers, co-writers who are all from very diverse backgrounds, because I want kids to be able to see examples of themselves doing, really cool things in STEAM. I feel like the key to pursuing careers that you may not feel like necessarily you fit for is to see someone else doing it. And for me as a kid, that was like Mythbusters and stuff like that, seeing examples of people who look like me blowing things up. I mean, what's cooler than that? And for the longest time, I didn't think I was going to pursue an engineering career. People can be very, very mean about it. And I feel like the engineering community as a whole can be quite difficult to be around sometimes and discouraging. So it took a lot to overcome to say, okay, I really like this. I'm going to pursue it, even though I'm like one of two girls in most of my classes. And it can be very difficult, but it's definitely worth that pursuit and, fighting to overcome that. So I've accomplished my goal through classes, robots, books, and more. So all the books that I've created are offered to children for free. The robots that I create are offered to children for free. The classes are for free, all that stuff. It definitely means I'm broke because I pay for a lot of these resources on my own, just because, people can donate money, but you always want to spend more. So I have different financial distribution models and all that stuff. And I'll talk more about that when I introduce the robot in a second. But it is really cool because the community has definitely rallied around me to be able to bring my resources to kids for free. SolidWorks, for example, they donated resources and the space to be able to assemble 150 of my robots at their 3D Experience World Conference in Nashville in February. And that was really cool opportunity. A lot of people got together and we all assembled robots just together. And that was definitely the most stressful event in my life. Putting together 150 robot kits is no small feat, even for a simple robotics kit like this, mostly because I had to solder every single motor controller. But it was really, really cool. And since the beginning of my organization, I brought my books to over 15,000 children around the world for free, and I brought my robots to over 4,000 children on my end. I also have a virtual learning platform where you can download CADs and stuff. But on my own, I've distributed over 4,000 robots and stuff like that. So regarding the children's books, I mentioned this a little bit, but I've written 5. I have 1 coloring book, and I have a series on the way. I'm working on a board book, and I'm working on an activity book, and I'm working on a memoir with a publisher. So a lot of writing. I'm definitely an engineer more than I am a writer, but it's fun. So these are the covers from my series. It's called the STEAM Cultural Connection series. I am no artist by any means, but I still wanted to get my resources out there to kids as best as I could. I was kind of like, I don't want to hire anyone. I just want to do this right now. So I did it, and the kids absolutely love it. I bring it to children's hospitals the most. And my favorite books to illustrate were definitely and write as well, would be the technology and the engineering books, just because I think that's more fun than science. And then these are some pages from the coloring books that I made, like the little activity book. This is an Indigenous girl and some simple math for the kids. This is on environmental science, and then also art. I think art is a huge part of engineering, whether it be through your mechanical design or whether it be how you document and express your ideas. But I think it's a valuable skill to know, especially if you're doing presentations, if you're working with people, stuff like that. So I try to teach kids those skills as well. But definitely robots over anything else. I also teach recycling education as well in the combination with the robots, and I'll talk more about that in a second. And then these are some illustrations. I've improved a lot, but I'm still not all there, that are from my upcoming board book series that I'm working on. And it's basically going to be introducing young children to very technical concepts like what is soldering, what are circuits, things like that. I haven't seen a lot of books like that for kids, and I think the best way to ensure competency in these topics is to teach them from a very young age. I wish people would have done that with me. So introducing Every Kid Gets a Robot. Every Kid Gets a Robot is my robot that costs $18.95 and goes to kids for free. It consists of four, oops, I have an alarm going off. It consists of 4 3D printed pieces, and I designed it in SolidWorks, of course, in the beginning of 2019. And this is the biggest project that I've created that has helped, bring me to larger audiences and help me do really cool projects and things like that. I just this past weekend introduced a new virtual learning model. But a lot of educational robots and RC cars, so remote controlled cars on the market right now, are not affordable, really. And if they are affordable, they often don't teach a very comprehensive look at mechanical engineering, electrical engineering, computer science. So I really wanted to do that. So that's why I created Every Kid Gets a Robot. It's printed in PLA, which is polylactic acid. It's a bioplastic. It's also biodegradable. Not the best, but it's better than other plastics. And it's actually made primarily out of cornstarch, which I think is really interesting. I print it usually on the Cindo 3D Wax DP200. Not my favorite. I think Prusa's are the best, but it is really cool. And I'm going to stop screen sharing so I can show you all in person. I think my camera's on. I'm not quite sure. I can't see anything. So this is Every Kid Gets a Robot, and it's a very simple robot, but it teaches the kids how to engineer their own robot in a very project-based way and also a very simple way. So I teach kids grades K through 12. And then we can see right here is up close. These are hexagons or benzenes because the main robotics team I work with is benzene bots. So I designed it to look like this. It's also a branding thing as well. It's very unique. I have a simple circuit, super tiny, right, so that the kids can add on to it. Again, this is very simple with it, but I just wanted to be able to introduce the kids in a simple way. I also have printed in stainless steel. This is 3D printed, and this is designed in SolidWorks. This is the chassis, and I'm actually working on getting this patented. This is where the microcontroller goes, motors, battery, motor controller, stickers, back wheel. And I will finish presenting. I'm almost done because I know I saw some comments. Okay. So this is what the technical illustrations look like a bit more up close. I have the front wheel. They have rubber bands on them for traction. I have a chassis, which is 3D printed as well. All these components are 3D printed. And again, designed in SolidWorks. And then the thin back wheel. So these are the front wheels, the rubber bands. And all of this is for affordability's sake. It is very hard to get a price down this low, but especially to get prices lower, often you need to work with a manufacturer to make that happen. I wanted to have that low price from no matter where they were manufactured, so that is the case. And then this is the robot in SolidWorks. And then this is a Adobe Dimension render of it. I am by no means good at it. I just started Adobe Dimension, but I have been, I think it's fun for the kids especially. I also use SolidWorks Visualize. So I think I talked long enough. I'm open to questions or just a conversation or whatever you guys would like to format it. But thank you so much.
The question from Harsh Kumar is, it will be helpful if you tell us how to you get these ideas. So it's basically asking for the inspirations for your ideas. How do you get those?
I was inspired the most by the communities that I work with and seeing. I work with a lot of kids, especially with learning disabilities. So I wanted any engineering solutions I had to be simple and effective. And so I studied other robot models on the market, especially for like every kid gets a robot. And that is how I was inspired to come up with a robot. But mostly it is just playing around in SolidWorks and designing solutions that I feel like are effective for the students, and then 3D printing it to prototype it, testing it, and then editing it. So yeah.
So the next question is from Aryan. STEM field is a very much famous. What are your sources of inspiration to introduce STEAM concept, the one which involves art? How this the idea strike your mind?
I feel like digital and technical skills are extremely important in modern careers. Having skills in SolidWorks, having skills in electrical engineering, everything like that are very important. And so I want to be able to tackle that as best I can by working in an affordable way to reach those students.
Okay. The next question is from Tanishk. I think 3D printed technology is not available for everyone. So can we manufacture robots by scrap material?
Yes, I actually have had students make robots out of toilet paper tubes and things.
Also, that's my personal question. You earlier mentioned that you are highly passionate about biorobotics and biomimicry.
Mhm.
So, how do you work on those? So, what are your basic inspiration? So, once I watched a video, you might have watched it. Meher Garimella, he used the concept of house flies and implemented that to a drone. So, what are your
Mhm.
views? So, how can we have such an inspiration for bio robotics?
I was the most inspired by seeing different robotics projects on YouTube. I was inspired by the Velux robot, which mimics a cuttlefish, and it can go on the land, the sand, snow, ice, in the water. And I'm inspired the most personally by implementing robots that can go up steep surfaces like mountain goats. So similar to like a spot robot, but up very, very steep surfaces. So yeah.
So, does anybody have any other questions? They can write in the chat boxes. Seems that we don't have any more questions. So,
I see one here. It says, how can one start with robotics? There are affordable kits online that you can get started with. Usually they cost like $50, $60. Or you can even download the different CAD files and buy the resources for like the auto DIY robot and getting started with that. And if you want to scale bigger, I suggest mentoring a youth robotics team and seeing how they do different things. And you can use that to improve your skills in engineering.
any other questions could be accepted.
Yeah, I know I went through quickly my presentation.
So, okay, I do have also another question. Have you
Mhm.
worked on ROS? ROS is considered to be the one of the best industrial grade software. So, if you have used it, what was your part? So, how did you do practiced it or implemented it?
Can you repeat that? Which software?
ROS, Robotics Operating System, ROS.
Yeah, I have used it a little bit, especially in my experience with manufacturing robots. So I work right now in the automotive industry personally, like that's where my office is right now. This is my classroom. I work in control systems in that. So electrical engineering, software to be able to control the stamping machines, and also designing manufacturing robots. But most of my day-to-day now has switched to teaching students. So while I love engineering, a lot of my stuff has switched to studies and also distributing and inventing robots.
Thank you, Ms. Danielle. It was very grateful for, and we have another question, so we'll take that quickly. The question is, can you tell us some technical terms while working with bio robots?
I'm not quite sure what that means. If you mean like, you know, microcontrollers, what I would be using, different circuit design, stuff like that. Personally, in the robots I'm designing, not necessarily bio robots, I work a lot with Arduino Megas, Arduino Unos for different, you know, bigger robotics projects that I do with my students. Like I built large droids with my students to play pranks on people. But mostly I don't know because I'm double majoring in mechanical and electrical. There isn't an undergraduate program in bio robotics really. So there's a lot I don't know. So I want to study it and you know, pursue a PhD in it. And luckily there is a PhD in it, so I can pursue those careers.
The next question is, what is the age group of students on which you focus to give them the knowledge of STEAM? Also, what are the challenges that you face while giving them the knowledge?
So I work with kids in grades K through 12, but I primarily work with like 10 through 12-year-olds. And mostly children in my own community. And the biggest challenge I've had when working with the students is not necessarily in the actual giving them of the knowledge, but how expensive it can be to give them the knowledge. Science and programming education is oversaturated because of how inexpensive it is to teach, but things like robotics, CAD, stuff like that is harder to teach because it costs more money to do so. So the cost factor is the biggest challenge I've had and is also the thing that I work the hardest to overcome.
The next question is, ma'am, have you ever participated or seen RoboWars? Can you guide students to make these robots?
I have seen RoboWars. I have been asked to be in a couple of the different robotics competitions, actually. I have a contract with Disney, though, so I can't do them, unfortunately. But I think they're really, really cool, all the robotics competitions and stuff. I love the idea of destroying other robots and things. And I could guide students to make these robots, but the biggest factor that contributes to not doing so is how expensive the robots are and how quickly they're destroyed. It's just not a sustainable model, especially for younger students. So to be able to teach that, you need a lot of money, a lot of resources, and a lot of mentors on hand to be able to do so.
The next question is, since tech-based entrepreneurship is one of the emerging field nowadays, what are the basic things you keep in mind while producing a product for commercial production?
Can you repeat the question? I'm sorry.
Since tech-based entrepreneurship is one of the emerging field nowadays, what are the basic things you keep in mind while producing a product for commercial purposes?
Expandability, I would say, being able to reach many different markets as quickly as possible, which is why, like, regarding my robots, I've been working on designing my own PCBs, printed circuit boards, as well as all of my tech on my own so that I have infinite scalable capabilities. If you use resources where you have to, like, give royalties to different companies. Like, for example, SolidWorks gives royalties to Siemens. And because of that, they're only able to have such infinite scalable capabilities where at a point, their competitors have cheaper resources and they can only have their price at such, you know, a low percent. So, like, I believe one software handles like $3,500, right? And they physically can't go lower than that. When coming up with new technologies and new companies, you have to keep those things in mind. Very future and forward thinking to know that whatever you're creating it has to be scalable, and it has to be, you know, you have to be able to work with different manufacturers. You have to be able to bring it to different markets. So it's just thinking, how is it going to be introduced to different people? And I know for me personally, I'm a very engineering-minded person. I am not a business-minded person as much, but it's worth it to take that time to research different financial information and to bring in business people and inventors to help as much as possible. Otherwise, your competitors are going to beat you. For social media handles, do you want me to just stick it in the chat for them?
Yeah, sure.
All right. I do not use WhatsApp anymore. But I am on Instagram.
The next, we have sufficient time. We can have a couple of more questions. So the question is, what should be the precautions to be taken while designing a robot?
Be followed by the robots. So there's different laws on what can be shipped, like different tech equipment. Like for example, over India, I cannot ship the robots, but you guys could buy the resources on your own and download my CAD files and make your own robot. So it's overcoming challenges like these to be able to further distribution. And because I work with so many different students from all over the world, I know of these challenges and I'm able to overcome them. But it's just understanding like, where is my target demographic and how can I actually bring my resources? And also another thing is that because it's marketed as a kit, I don't need to pass a lot of the safety regulations toys do. For example, like children can swallow things. And if you market it a certain way, there aren't as many challenges in the United States, at least in my state. So that is something. It's just knowing what the different challenges are and what you have to do to overcome them, or how much money you have to spend to be able to, you know, answer those solutions.
This is the last question. Can there be some protocols or laws for the countries to be followed by the robots in the near future?
Yes. So yeah, as I was saying, basically there are different laws and things that you can overcome and work through, like for example, the sending the robots overseas, or you know, safety testing and regulations for like children. If you're making a product for kids, that can definitely be difficult.
So thank you, Ms. Boyer, for it was our great pleasure to have you as a guest, and we'll be expecting you for another session. Thank you.